Good morning, good morning, good morning. Welcome back, guys. Official welcome back to your lecture with me. Um, I think this will be my last semester on the National Diploma in Marine Engineering, lecturing the chiefs. I think next year I should be lecturing the year zeros, the ECPs. Um, so we're definitely gonna have a good semester. Definitely gonna learn new things. Some of you guys have been here. What's the TS for? What's the TS for? Um, yeah, and I look forward to you passing. And we want a 70% pass rate here for the subject, and we'll strive to get that. Um, Unfortunately, it will require some work, some commitment, some staying sober in all domains of life, and yeah, it's and I as with 100% of a community here, and want to ensure everyone gets through without failing. And once again, we don't believe in intelligence, talent. We believe in hard work, discipline, and perseverance. That is our language. We talk here. We push to get what we want. And I'm always at the backdrop if you guys need any assistance. If you can't make a test, if you don't understand a concept, I'm more than happy to always you know to guide you. Anyway, so this is the timetable. Obviously you see me on Mondays as per the timetable, and excuse me for sharing the wrong one. Well, it wasn't correct, the one I screenshotted or slip tooled. I see you on Mondays, that's our slot. However, I might be having bonus sessions, and I would want you guys to be cognizant of it. It's either on a Wednesday or a Thursday. Um, Please, I can announce it on Blackboard. Someone the class can just remind me. Just after the lectures I might have it on campus or online, depending, where we can have like maybe sometimes I know with mom, sometimes you're gonna struggle to finish the content, and then maybe I can use that tool just basically an hour and a half, whether it be online, whether it's at home already, or we can have it on campus while you're on campus, just as a kind of a tutorial session of some sort for certain things. So I'm making you aware that Wednesday and Thursday I am parking, if required. Definitely not on the Friday. It might not be both days. I might be doing it on one Wednesday a week or one Thursday. But I'm just letting you know I will be using it so that we can finish the content. And if there's any questions, things like that, because definitely the 4 periods is definitely not enough. Um, Depending, yeah. So I'm just making you guys aware of that. Guys, these are my consultation times. Yes, is the question maybe. Period 7 on Thursday for some. Oh, what's this? What's to say? Period 7 on Thursday for us. Some of us will have NAVOC. Period 7. Uh, but isn't NAVOC finished at period 6, Mr. Duplessis? Period 6 is moved to Thursday. Ms. Ndima, I'm not sure what's happening on your screen. Mr. Naidu told me, yeah, period 6 is moved to Thursday. Yeah, that's correct, yes. Yeah, so no, I'm talking about after that. I'm talking after lunch, if that's clear. But it shouldn't be period 7. Otherwise, just send me a WhatsApp. We'll sort it out. At the end of the day, it's just an intervention. Otherwise, you just use Wednesday. Maybe I'm missing something just like before. Okay, cool. That's no problem. Anyway, yeah, that's just like some backup, right? So and I'll let you guys know in advance, obviously. So you don't have to really be concerned about it. My consultation times for our repeaters, Monday after class, you can engage with me on WhatsApp, email. I can assist you. So try to work ahead. If you have a problem or two, you can just send it to me. We can discuss on Tuesday. That's in the mornings. Um, should actually sound available that day because I use the morning sometimes for prep. And Wednesday and Thursday is from 12 to 4 as well. So, and then Friday I'm unavailable. I should actually put unavailable on Tuesday. But nevertheless, you guys should always pop my WhatsApp and I'll respond. I mean, even on the bloody weekends, you guys still bother me. But please try to respect my times. Um, but yeah, always just send me a WhatsApp anyway if you're battling with anything. I will attend to you probably during those times. I think that's what I mean. Okay, so for the guys who weren't here last semester, hi, Mr. Sima. Good to see you on. Just as a somewhat reminder, what a reminder, just to let you guys know what we covered. We covered 7 topics, and it was quite dense. A lot of concepts was being thrown around, and yeah. So we did inertia, systems with friction, relative velocity, centrifugal force. We looked at conical pendulums, governance, balancing, vehicle stability, a lot of basic stuff, mass moment of inertians. We looked at actually a few things there, different forms of shapes, um, different axes as it rotates, um, simple harmonic motion, which will be a small, only the compound pendulum, which is kind of brought through MOMS 3, and also there are some applications of mass moment. So we basically looked at hoist and haulages. We didn't look at gearing dynamics, but we looked at the rolling and slipping of objects. Typically, you can also include vehicle dynamics, which you didn't look at, and then lastly was belt drives. So what heat engines 3 is essentially a continuation of MOMS 3, but at the same time, it's at the second half, which is around, which I kind of range things a bit. It incorporates very small concepts from the previous semester. And what I mean, like for instance, in shafts, you'll be using, which I'm quite excited to teach because it wasn't part of the syllabus, not part of the syllabus, but I never did it last semester. You need to be able to do your shear force and bending moment diagrams over there. You have to be able to use your torsion equation to find the diameter of the shaft. For instance, at energy systems, it requires you to know, well, obviously there's rotational hoop stress, which is rho equals, it's a function of the density of the material and the velocity squared. If you guys recall that in thin-walled cylinders instance. Inertial forces incorporates some thermodynamics as well, and obviously some stuff of machines. So there'll be no really finding mass moments of objects. Typically at this level, mass moments will be given to you as a value, assuming that you understand what it means. In the context of obviously something that has more rotational inertia or mass moment of inertia, it'll take longer to rotate. Obviously, when you do analysis, it'll give you an idea. Balancing is a continuation of the previous one. We looked at everything in the same plane, and what we're going to be looking at is masses in a different plane. So that's going to be a nice build up. Invalid gearing, it's normally thrown in the end, but it's going to be thrown just with all the transmission elements. I like to do gear trains, but it's going to take too much time. But the first 2 chapters essentially are 3 marks. And I think, and as the chapters progress, it gets more interesting, especially, yeah, it gets more interesting, but it also can get a bit more challenging in the way that it requires some S3 content in order for. So those are 7 chapters. I'll try to show you where you are progressively, but this is what will be covered in the 15 or so weeks. And I didn't paste the schedule up yet. So I have the schedule on another document. I can always do that next week. But these are this is what's going to be mastered. Everything's on Blackboard already in terms of notes, and yeah, that's what essentially you have to practice. Cool. So recommended textbooks. I've shared this on Blackboard, the Theory of Machines one, and the N6 textbook from Peter Toit. I've shared the relevant sections there for you. There are some other recommended textbooks that all deal with theory of machines. And yeah, so you've got the whole textbook there. If you like a hard copy, what I recommend you to do is print out the individual chapters of the textbook, which I've sent, or this one. Put it in a LibreArch file, and yeah, then you can have them like that. That's the, if people really want a hard copy, that's what I would recommend. Cool. I'll be talking for long, guys. You know, we work here. Cool. So that's that. I think that's kind of clear. Has everyone received the textbook via Blackboard? Can I just confirm that? Hello? Am I still audible, guys? Are you guys still there? Mr. Watson, did you get me? Mr. Smolders, are you still sleeping? You guys get the textbook? Thank you. Mr. Zita? Did you get it? Oh, I'm with you, Mr. Duplessis. I see it. Fantastic. Fantastic. Cool, cool, cool. Mr. Duplessis, did you get the textbook? I'm sure you want to work ahead. Unless you can't find it. It's on the group, man. Let me just reshare it quickly. Let me that's what I'm looking for, like when you accentuate it again on the thing. I'll find it now. I sent the stents ones as well. I mean, you know. Did I not send it here? I did send it. I can see it on the group. I'm just trying to look for it now. The strengths. Oh, here we go. Here we go. So let me just. Cool. Send. Group or Blackboard. It's on the group. Yeah, there we go. Nice. Okay. Mr. Brett, did you obtain the textbook? Sweet. Okay. Yeah, so obviously for those who want to follow, I will obviously give you time. It's the first lecture. I'll somewhat go easy on you, somewhat. All right, so let's move on. Okay, so because I'm only lecturing 2 subjects and I've got around 50 students per 50, around 50 students. I think electors is more. 50 students per subject. We're gonna go with a 20-20-10 fees of 50, and those dates. So our first test, apparently the 4th of September, which I highly doubt. People are gonna probably change dates and stuff. I might make that date after the break, but we'll see how it goes. But for both my tests, so that'll be probably after the term break, which I think it's the term break's around the 19th or something. I don't know if we get back to 19th. And it'll cover sections 1 to 3. Probably 4 questions in the test. Test 2 will probably be the same, or 3 questions. Definitely 3 questions because the content is dense. And then what's cool, you're gonna have an assignment, maybe a design type assignment on chapter 4. I shouldn't say beginning of the 4th term, actually. It's in the 4th term. However, I'm still deciding on the 10%, but the 10% is for the little boys and little girls, just in case they don't make don't have enough marks. So it won't be a straight 25, 25. So you've got a 10%, which will be for you, given that you worked. I've done this with electros. Surprisingly, people still didn't do the work in time. Some people did extremely well. But guys, please, that 10% is the difference between you writing either passing or writing a reassessment. So please, when you sign us come out, and there will be a group assignment just for the ease of marking, which makes it even better for you, so that you're able to work together and make sure you secure the 10%. So the 10% is literally for you. Make sure you get it. And then obviously the test, the 2020 will be on yourself. And then obviously the final will incorporate all 7 chapters. I always like to say this to my students. The final is essentially an amalgamation of test 1 and 2. It doesn't, the difficulty doesn't increase at all. It's just 7 chapters or 6 chapters within the exam you have to do, and you are required to do it in 3 hours now, and that's where the intensity comes. So the content you've went through the content. The content is difficult by the virtue of it being, at the university level. And also the content requires a lot of backdrop of information in terms of, like, you need to get to a certain point to understand it, but it's not difficult. If you get through the semester, if you go over test 1 and go over test 2 literally together as one test, one exam, that's what the final will feel like. 3 hours for this type of stuff is a bit intense. Because obviously you have to do a lot of thinking, and you have to be quick with the pen. Especially with this course, you need some tools which we'll talk about. So that's the assessment style I'll be using for moms and electros. Obviously for electros, I will talk about that. Electros assignments, I'm a bit more clear on. For moms, I'm still in between exactly what I want to do. I know what I want to do, but I'm still deciding, am I going to go with a full 10% or 2 5s and things like that. Just give me a moment quickly. Fantastic. I think I was a bit this early on. Okay, cool. So I hope that's all clear. So 2020, that's a definite. I'm not going to be changing this. So yeah, so that's good. Tools for the course. Our beautiful Casio FX991 ES Plus. It goes without saying, helps us with many things. And then you require some set squares. Um, that's a picture of the ones I took, right? Was it from the internet? I don't know. Yeah, that's the ones I bought. You can also get the adjustable one, which is both 45-degree and 60-degree. Thank you for Annecy, we just mentioning that. And you obviously need to protect as well. You'll see this in balancing. We're required to do graphical methods as well as analytical. And also this is also in velocity analysis, where it's exclusively graphical. Which is what uncomfortable to students. It was uncomfortable to me when I learned it. It really caught me. But it's the content we need to cover. But yeah, it should be fine. It's not too bad. Cool. Again, what's expected from you, your responsibility. I just always really want to highlight this because it's just important that you know that this is on you. Make sure you take notes and solve examples during lectures. So once I'm solving example, go with me through it, get the understanding, follow me. Don't sit and listen to me talk, especially when I'm solving examples. This is a hands-on sport, arguably a hands-on sport. Ask questions. You guys pay school fees for knowledge. Ask any question. I'm here to make sure you get your answer. That is why I'm here. Try to complete all the exercises. I said around 70 to 80%. You don't have to complete all of them, but make sure you put in the reps, and the sets, just to cement your understanding. Check Blackboard daily, along with student emails. I'm always uploading stuff. I get annoyed when students ask me, is it on Blackboard? I'm pretty sure it is. And thank you for those who remind me if I didn't put it on. Complete all the tutorials. You'll see. I'll always mention, do this, do that. And obviously I'm mentioning it for good reason. There is past papers. I have some two tests which I've developed last year, which is on there. Yeah. And in terms of past papers, all the content which is in the exercises, the notes, and tutorials, that'll be your essential scope to master. Nothing more than that. Rewatch lectures as many times as possible, guys. That's the point of online lecturing. And I do some online courses on Udemy. It really works well. You can go back and go watch something. A lot of people don't want to rewatch something. I've come to realize, take the time to rewatch it. It's not gonna hurt you. So and sometimes even when you're rewatching, you literally can be practicing as well. I mean, Alex had a good point in orientation of just you do it yourself and go back. Um, you can also watch additional YouTube videos. I am not the absolute source of these materials. I didn't create them. These theories are developed by a lot of other people. A lot of other people can articulate it better. Watch extra stuff to make your understanding better. If you haven't seen a clutch, for instance, go watch a video on what a clutch is. You know what I mean? Or a belt drive or whatever. Well, we should have seen one at this level, but you know what I mean. Again, a rigid study schedule, 3 to 4 hours a day. I know it's intense, but it's necessary. Start with 1 hour, start with 2 hours, you know, like start with 5 kilograms in terms of your benching, and go to 10, and then go to 50, and then go to 100 eventually. So start, be disciplined. Another one which I've added is exercise and healthy diet. Guys, big on this now. Like really going for a jog, lifting weights, and eating right really helps with that extra energy versus eating at McDonald's or at Gatsby or whatever you guys are eating. Watch, don't eat too many processed things. A healthy diet is key, right? And obviously exercise. That gives you more energy to study. If you hit the jog in the evening, you can definitely surely you'll push more hours and at night, or the other way around in the morning. So it's really, I really believe in that. You know, it's mind, body, and soul. You can't neglect the body there. And the infamous 49% is a fail, 50% is a pass, and 51% is neglecting your family and friends. So we know that implicitly means you got to work hard, right? Everything comes to a stop. I am your husband, I am your wife, I am everything now for my subjects, and you make sure that you focus on this. And it's only 15 or so weeks, then it's behind you. Then you can even enjoy your holidays or go back to sea. All right. So we're gonna start the official lecture. And yeah, is there any questions before I start on the official lecture? Any administrative things I need to address? Yes, Mr. Wehrling.
Yes. So, with this set squares, what size must they be? Because you get the drawing ones, and then you get, you know, the small little mini compass ones.
Yeah, it's like just get the bigger ones. Some people can use the smaller ones, but I recommend getting the bigger ones. It's just easy to maneuver when you draw the velocity diagrams. So like it's like, yeah, my ones are orange. It's those ones there. Like it's around 20 centimeters for the 45, and then no, for the 45 is around 16, and then for the 30 and 60 is around 20 odd centimeters.
Okay, that's perfect, sir. Thank you.
Yeah. Cheers. Yeah, we'll be needed in like the next two or three chapters, so you'll see. Yeah, and makes it a bit fun. Some people will like it, some people don't. Okay. Any other questions before you move on? Time goes so fast, damn. Again, time settings. So change my time quickly. Our time is wrong. Okay. Okay, cool. Doesn't look like there's anything else. Let me just get back into Blackboard. Cool. Okay, let's move on. So where we last left off, excuse me, is we looked at transmission, right, which is on belt drives, and I posted a recording for that. And obviously, the purpose of a belt drive is to transmit is to talk well it's basically to transmit mechanical power. And in fact, with mechanical transmission, there are two types, right? Typically, there's positive drives and there's friction drives. So positive drives are, are ones where there's no slip, right? So obviously, belt drives falls under the friction domain where there is some form of slip. I can give you some examples of positive drives, and those are things like shafts, because obviously a shaft transmits mechanical power. And when I talk about mechanical power, what I want you to pay in your mind is 2 pi n t divided by 60, or rather just power is a function of the torque multiplied by the angular velocity, right, or the rotational speed, if you like. So like I said, some positive drives or shafts, flange couplings transmit mechanical power, gears, and dog clutches. Friction drives are typically have friction discs. So obviously with friction drives, you typically have two surfaces touching other. Those are like friction discs, which we're talking about. Vehicle tires is transmitting torque. Friction clutches, belt and rope drives. And obviously with belt drives, which you touched on, it was an idea of a you know of a friction type. So anyway, the whole purpose of all of this is, on our holistic views, that we transferring torque from one place to another, and we need that for several reasons. And what it says here, mechanical power transmission involves using different types of systems to transfer energy from one component to another without changing its nature. For instance, what they mean there is like, when you get a generator, we typically go from mechanical power to electrical power. That's what they mean. So we stay within mechanical power. Also, when motion coming from a driving mechanical component is transferred to another without being changed, there is power transmission. That's the idea. So we're transmitting power in the mechanical power transmission system. The moving component transfers the energy to the receiving component. Maybe, for instance, the pinion and the gear wheel, or the smaller pulley to the big pulley. These two components can be directly in contact, but can also be transferred by intermediary contact. Obviously, in this case, the belt drive would act as the intermediary component. So that's what typically things. So just like classifying and further breaking it down, transmissions or mechanical drives, like I mentioned, there's positive drives where no slip occurs. You've got your chain drives, your gear drives, and then you've got your frictions where you've got your belt drives and the ropes. Belt drives can further be broken down into flat belts, V belts, timing belts. Um, yeah, no, that's forms part of flat belts. Anyway, that's that. Then on your gear drives, you got a whole range of types of gears, which I don't think we're looking at all the different types. So there's not a gear type course. But anyway, so that's under that. Um, and yeah, so just to give you an idea of what all of this is. So before I go into all the theory and how we model the stuff, I like to ask all the experienced engineers, and maybe not so experienced engineers, what is have you guys worked on clutches? Is clutches important in a marine engineering domain? What are your experience with clutches as a marine engineer? I'm opening the floor to anyone. Mr. Plachis, do you want to go first? Or Mr. Zita? Who's worked on clutches? Mr. Beard, Budalalo, Mr. Sima. Anyone? You guys know what a clutch is? You haven't seen a clutch before? Let's see. I haven't worked with one, but the centrifugal purifier has it a bit. Got it. Oh. You work with cone clutches, Mr. Smolders, on power boats and so on. All right, doesn't seem like everyone worked with clutches here. That's cool. Okay, the service didn't come on board to overhaul the clutches. Okay, so you guys didn't work on that. But anyway, people are aware of it. Nevertheless, I thought we could share some experience with clutches. Okay, nevertheless, we can move on. Okay, so in your textbook, shared on a blackboard, it's chapter 10, and you have to go to page 297 to where it starts on clutches. So that's if you want to obviously follow, follow the, because I've kind of, did I go with that flow? Not really, but yeah, um, that's, that's the text. That's the text. Okay. Yeah, this is some images. No, why it's SD. Okay, so what is a clutch? I think I'll refer back and forth to these things. A clutch is a device used to transmit torque. So just like I mentioned in the introductory part, that it's all about mechanical power transmission, and it's used to transmit torque between two axial shafts, right? It enables the shafts to be engaged and disengaged while at rest in a relative motion. So while at rest or in a relative motion. So basically, what it means that you could have on the engine side and the flywheel rotating at a specific amount of torque at a different speed, and then maybe the driven shaft you actually want to the other part of the side. Basically, the clutch is just intermediately in between the two elements to make it rotate at the same speed, and it basically transmits the torque. Nevertheless, for this to happen, the contact surfaces should develop a frictional force that will pick up and hold the load with a reasonably low pressure between the contact surfaces. Obviously, we'll talk about this. Theta friction should be rapidly dissipated and tends to grab should be the minimum. We don't want it to, we don't want too much heat. And the surfaces will be packed up a material stiff enough to ensure a uniform distribution of pressure. Some more definitions of this. Okay, obviously they have this is just like a gear train, clutch moving back and forth, gear train rather, moving back and forth. Yeah, engaging and disengaging. Sorry. A clutch is a machine member used to connect the driving shaft to the driven shaft. So again, with the engine side and the flywheel, and then obviously the driven or the driven shaft on the other side. So that the driven shaft may be started or stopped at wall without stopping the driving shaft at all. So we don't want to stop the stuff. So one will be rotating and we're able to, make the changes and so on. A clutch thus provides an interruptible connection between two rotating shafts. Hence, it's a key element in changing gears, right? Clutches allow high inertial load to be started with a small power. That's quite interesting. And also, a popular application of clutches in motor vehicles, obviously, where it's used to connect the engine and the gearbox. That's the primary form of a clutch device now. But in more modern electric vehicles, they've eliminated transmission completely, and that's why mechanical engineers in the automotive industry will lose their jobs because we work with motors basically coupled to the wheels now, and we directly control the motors through like VFDs and things like that, variable frequency drive with speed drives, and there's no need for transmission anymore. So yeah, it's kind of an old, outdated thing. Also, the clutch enables the crank to start the engine, disengaging transmission, disengage the transmission and change the gear to alter the torque on the wheels. Obviously, once we engage and change, the torque will change depending on your ratios. And clutch you also extensively use in production machine of all types. And follows the same kind of type of application there, where we require more torque or less torque. It's the clutch and the gearbox essentially. For the classification of clutches, luckily we won't be looking at all of them. You've got your positive clutches, your dog clutches or square jaw, spiral jaw. That's just for information's sake. And then on the friction side, you've got the centrifugal clutch, usual like lawnmowers and things like that. And you've got your cone clutch as well, and all the others there. And then you've got the plate clutches, which we'll be looking at, the single plate and the multi-plate in particular. Okay, so for displacement clutches, spline type clutches, well, what are they saying here? They're used to transmit power when there's a velocity ratio between two shafts, must be coupled, must be constant. The common type of dog clutch, claw clutch, distinctly used to engage different ratios in the gearbox of a motor vehicle. So there's this type, which is more for information purposes, and there are two types. You get the square and you get the spiral jaw type. And the merits of these is that there's no slip, and there's no heat generated through this. So there's like a gate type clutch of some sort. Just for noting really what a positive displacement clutch actually is, but we'll be looking at those. We're looking at the friction types anyway. Okay. So friction clutches, like I mentioned to you, it's classified into the plate clutches, so those clutches, the single multiple, right, which we'll be looking at. Cone clutch, thought of throwing that maybe in there. I'll see how it goes. And then centrifugal clutches, which we won't be looking at, but I'll mention that again. It's also part of the syllabus, but it's kind of an overkill. And then once again, there's two different parts, which I'll talk about now. So two shafts not running at the same speed. And then what's going to happen with the clutch is that slipping, when the clutch engages, slipping will occur between the two shafts until they're brought to the same speed. Super important thing to understand because we're doing the maths behind this. Once this happens, the torque will be transmitted, and then no slip, unless the limiting friction force between the surfaces is exceeded, which typically doesn't happen, but it does happen sometimes. I don't know if you ever heard your clutch slipping. Someone mentioned things like that. That's when that basically happens. So one thing on the having in mind, we're going to look at the analysis of a clutch individually, and then we're going to look at it holistically from a mechanical dynamic perspective, where we incorporate the inertia and stuff. That's the fun part, which I like. So two different shafts rotating at different speeds, different torques. The clutch basically marries them together. Some friction occurs, some slip occurs, and eventually doesn't slip. And then eventually they all rotate the same, they all rotate in harmony, and yeah, kumbaya. Okay, so again, what I basically mean is this, where you could imagine you can look at either diagram, on the right maybe, where we have the engine flywheel side, where the engine produces its own torque at its own speed, and it's my voice is a bit messed up here. Got a bit of sore throat, and then it has its own inertia. And on the other side, we have the driven shaft, whatever that be, maybe going to the wheels, whatever, gearbox, and the clutch, that the intermediate component, and as it comes together, it basically transmits the torque, like I said, and there's a bit of slip first, and there's no slip. So that's the idea. We'll look at it later on. Okay, so again, this construction of a clutch, just to get people aware of this before we get to the maths. The clutch has essentially three parts. It's the flywheel, the engine flywheel. Obviously, everyone's aware what the flywheel does. Provides energy. And we're going to be looking into flywheels fairly in depth, not only for automotive, also for marine type applications. It provides energy during certain strokes when there's no energy. This work is only done during the, for instance, at the expansion stroke, and there are parts where it balances out the work fluctuation. Nevertheless, there's also the friction disc, which is called the clutch plate and the pressure plate, right? So I'm sure people have seen this before. You've actually got the flywheel, and you attach the friction disc, and you have the pressure plate coming afterwards. Yeah, the diagram at the bottom shows that. And you obviously got your release bearing there, which kind of deals with that diaphragm spring, a line that pressures it the force and all of that. Anyway, this says when the engine is running and the flower is rotating, right? So flower is rotating with the engine. That's how it typically is done. The pressure plate also rotates, which is attached to the flywheel. That's yes. The friction is located between the two, right, as there is. And when the driver pushes down the pedal, so when you're pushing down your clutch pedal, it's released, and the action forces the pressure plate to move away from the friction disc. And then there are air gaps in between the flower and the friction disc, and then between the friction disc and the pressure plate as well. And then no power can't be transmitted. That's when you're pushing on the clutch, right? Or released, sorry. Now basic operation of the clutch is when the driver releases the clutch pedal. Yeah, there we go. Sorry, power can flow through the clutch, and then springs in the clutch force the pressure against the friction disc. So yeah, so that's the springs over there. This action clamps the friction disc tightly between the flower and the pressure plate, and now the pressure plate and the flower will essentially rotate the same. Do I have that image over here? Okay, this is just this when it engages and disengages. Oh, looking to the one side there, that's when they go apart, and then that's when they come in together. So they're going apart. That's like a very basic type illustration of what's actually happening there. Oh, that's what happens there. This is a very nice, I didn't reference this picture, but this is what the system looks like from the side, where you have your driving shaft and your driven shaft on the one side. The driving shaft is always from the engine side. It's put at its own torque, at its own speed. Flywheels there, and obviously on the left hand side we have the disengage part of the clutch, and then on the other side that's where we engage the two together, and that's when slip occurs, and eventually the torque can be transmitted from the driven shaft to the driving shaft. That's what should be running through your mind all the time. And obviously there's an axial force, which is or an axial thrust, as I say, which is being produced by it essentially happens due to the springs as well. The springs transmit that force coming through there. We will be doing some analysis on that. Okay, so let's see where we get the fun part. We're going to start doing some calculations. So the method of analysis, which is essentially the core of this course, we're doing a lot of analysis, is, let's read it. Torque can be transmitted by a clutch, and it's a function of geometry, and it's a magnitude of the actuating force applied, as well as the condition of contact of the prevailing between the two surfaces. Cool, right? That's fine. The applied force can keep the members together, and with a uniform pressure, with all this contact area, and its consequent analysis based on this uniform pressure. Well, in fact, there's two types of things we're going to look at. So the two theories we look at is the uniform pressure one and the uniform wear, just to give you an overview of what's happening. Excuse me. Cool. The first theory, right? And I want to use the word new. So when you buy a new clutch and you insert it, the prevailing theory would be the uniform pressure one. And what does the theory state? And obviously, you're not going to tell me in words. You'll be using the calculations based for this theory, but it's just the idea so you can understand what it means. So the uniform pressure theory is, the assumption is basically that the pressure is distributed uniformly over the frictional surface. So that's the surfaces essentially in contact, right? They're saying the normal force between the surfaces is the product of the pressure times and the contact area. Well, yeah. This type of theory produces a higher frictional torque compared to a uniform wear theory. Very important for you to remember. Very, very important. And if the contact area is divided into a number of concentric rings of equal width, the outermost ring will have the largest area compared to and it obviously decreases towards the center. They're saying the normal force per area will also decrease from the outer ring towards the inner. So, nevertheless, what it means is that for the UP theory, the uniform pressure theory, is that the pressure is uniform across the surfaces. Okay, the other one is the uniform wear theory, right? And in this case, the normal, or what they state there, is that assuming that the fit between the contact surfaces is perfect, obviously, the normal intensity of the pressure will be equal at all points of the contact surfaces. This theory is relevant to worn clutches because wear is uniform over the contact area from the inner radius to the outer radius. So when we're dealing with old clutches or worn clutches, right? This is the theory. Some of you guys haven't done your service yet. You probably, if you want to see how much torque you're producing, you have to use a uniform wear theory. And essentially what it means, if you look at the sketch at the bottom, is that, you know, the pressure is not uniform across the whole thing. And they say what's important to note is that the rate of wear between the contact surfaces depends on the intensity of pressure as well as the velocity of the rubbing between the surfaces. And basically the wear is therefore a product of the normal pressure and the rubbing velocity, which implies that the maximum pressure occurs at the inner radius, right? And they say P times R equals C. Yeah, nevertheless. So again, for this theory, the pressure is not uniform and it varies from inner to outer. And what's important here is that if they don't state which theory to use in your analysis, you have to use uniform wear. I typically tell you which theory to use. Excuse me. And yeah, so this is the other type, this is the other theory. And they say however, as the time progresses, some wear take place between the contacting members, and this may alter the varying contact pressure appropriately. And uniform pressure condition may no longer prevail. Yeah, so then that's when we use uniform wear. So yeah, that's just back to the two types. Okay. Get into the analysis part now, the equations and all the fun stuff. So what you have to master is these two theories, then obviously apply them. So first thing is first. Let me just get this. To calculate torque on the clutch, we use that formula at the top, which is N, which will be the number of frictional surfaces, mu, the coefficient of friction, obviously, W, which is the axial thrust, and R would be some mean radius, right? So that is a general formula for torque transmitted of clutch. What changes is W and R depending on which theory you're using. I hope that's clear. So I'll say that again. The general formula for torque basically is W times R, which is essentially force times radius, times N times mu, right? And what changes depending on which theory you use is the uniform pressure. It's depending on the theory, whether it's either UP or UW for uniform pressure or uniform wear, or be W and R. So what do I mean by this? So for uniform pressure, to find the mean radius, it's going to be 2 divided by 3, 2/3 times R1 cube minus R2 cube, which essentially means it's the outer radius minus the inner radius, all cubed divided by the inner outer squared. That's the first thing. To find for uniform wear, we have a different type of mean radius where we just simply take the average of the two values, right? So it's not too specific in terms of yeah, it's a very we just take a big estimate on the radius where that's acting. So I'll make it clear. So there's two different radiuses or mean radiuses or effective radiuses rather for uniform pressure or uniform wear, and you have to know which one to use. And for a single type, which obviously we do multiple, it's a bit different. Both those sides of the disc are effective, and therefore there's two plates in contact on the pressure plate side and obviously on the engine wheel side. And therefore, N for a single plate disc is always going to be 2. There's two sides in effect, right? If that makes sense. So we've got two sides. Essentially, there's a total torque being developed. Okay. Before I get that, I'm going to talk about the omega part. It's not omega, the W, sorry. And the W, if you look at equation, yeah, so for uniform pressure, if you're looking at A here on the left-hand side, that's how you're going to find your W. W is the actual force, so W will be equal to P times pi R squared minus your outside minus your inside, basically, right? That's demonstrated on the thing. And then if you look at B now at equation 7.2, just above 7.28. W equals P max times R1, which is also C, equals 2 pi R2 minus R1. So what I'm trying to just highlight here is that depending on which theory you have, they have different axial forces and they have different effective mean radiuses. What's important to note when you're dealing with your uniform pressure, because the pressure is not uniform across the frictional surface, you have to find the so-called C value, or the intensity of pressure, or whatever. It's given at equation 3 and 4, yeah, in particular. And for you to find the C value, the maximum, they always give you that P max value, and to find the intensity of pressure, all we have to do is times it by the smallest radius. So what you basically doing is you're just providing a number to demonstrate that's the highest pressure in the uniform, or that's the highest pressure acting within the uniform wear theory or on the frictional surface. And you obviously, I'll explain that all to you now. So there's some important notes, and I'll mention again. In case of a new clutch, if the word new pops up, the intensity of pressure is approximately uniform. But in an old clutch, the uniform wear theory is more appropriate. So when you are new clutch, use uniform pressure. When you are old clutch, use uniform wear. And obviously, if you think about, obviously, your uniform pressure theory will give a higher frictional torque than uniform wear. Therefore, in the case of friction clutches, uniform wear should be considered unless otherwise stated. I mentioned this to you. Okay, so I'll demonstrate this. These are additional formulas. You don't actually get them, but these are like, I just modified to make for you to, it looks a bit more easy to use. I don't typically use them, because I remember the older ones, but these are like, it makes things just simple for you to remember. You can calculate the torque immediately if you have all this. What they basically arrange in diameter and radius, or radius and diameter. I think we can see that there. So anyway, please, man, I'm talking so much, it's feeling like I'm anyway, let's hone in onto clutches, right? So we've talked about what a single plate clutch is: pressure plate, flywheel, clutch plate. And okay, let me just read this to you. Basically, it's a friction material, usually for rodo. I'm sure you guys have seen it before. It's mounted on the hub, which is free to move actually along the splines of the driven shaft, so it can move back and forth. The pressure plate is mounted inside the clutch body, which is bolted to the flywheel. We know that. Both the pressure plate and the flywheel will rotate with the engine crankshaft, and all of that to have its own inertia, or the driving shaft. And then the pressure plate pushes the clutch plate towards the flywheel by a set of strong springs, which is really inside the body. Obviously, we can see that over there. Typically 1, 2, 3, 4, or typically 6 springs. That springs, we'll find the magnitude of the force within those springs. And the 3 levers, known as the release levers or fingers, are carried on pivot suspended in the case of the body. These are arranged in such a manner that the pressure plate moves away from the flywheel by the inner more of the thrust bearing. So the release bearing I was talking about. You can actually use the same formulas for thrust bearings and things like that, but nevertheless, that's the explain of the bearing moving back and forth, going through there. So I don't want to talk too much. We can always come back here if we need, but we get a general idea of, you can see it bearing them up, engaged, not engaged, that kind of thing. That's what's happening. Cool. Flywheel, clutch plate, pressure plate, all together in one assembly. I've left some links for some YouTube videos. You can have a look at that. I think I explained it adequately, and we can actually just carry on. Yeah. So the last note in terms of words and stuff. Let's say consider clutch plate. This is in regards to the surfaces. It consists of 3 plates: the flywheel. You can see the flywheel. We've got the friction plate or the clutch plate in the middle, and we've got the pressure plate. Yeah, right. And they're saying there are 2 pairs of surfaces in contact. One on the flywheel side, like I mentioned, on the clutch plate side, and the other side is one on the pressure plate. And depending on how much plates we have, we can work how much surfaces are in contact. So obviously, for single plate clutch, we have 3 number of plates. 3 minus 1 will give us n equals 2. Hence, that is why 2 will always be the number you're going to use in that formula over there, the mu n mu w1. Obviously, when it comes to a multiple clutch, which is transmit more torque, n is not always 2. But the idea is that's where the n is 2 coming from. Like I said, between the flywheel and clutch plate, that's one surface. between the friction plate and the pressure plate, that's another surface. Cool. So let's finally start on an example. Is there any questions, students, before I move on? I know it's a bit of a mouthful, eh? Yeah, it's been a while. Any questions? Am I free to proceed with solving our first two examples? Don't worry, I've got some work for you as well. Any questions, students? I'm just going to copy the questions quickly. Any questions? Are you guys sleeping already? Oh, I got some actually comments here. I missed that. Better service team, I wanted to introduce. Okay. Bongani, Mr. Silva, questions, Mr. Smolders. Fantastic. Cool. So now we get to the fun stuff. We're going to be solving problems using the UP and the UW theory. Yep. So I've got two problems for you, and then you got one for yourself to solve. Nice and easy chapter. Nice and easy. Okay, so I'm going to do the first one, and this is just to get you acquainted to. I'll just reshare my thing. This is just to get acquainted to these you know, using that C value, which can be a bit. I'm going to unlock this. Okay, cool. So I hope you guys can all see this. I'll do this two examples, and we can take a break, and then you guys can do one and see if you guys are feeling it or not. Oh yes, by the way, this in the textbook, let me just check the page double quickly. So it's page 302. So I'll give you guys like a minute to find it, and then we can actually start solving it. But it's a very basic thing. Then we'll get to the crux of the matter. So yeah, page 302, I said. All right. So I'm assuming everyone has found it. So this is a warm up. Then we're going to go into a decent problem. Let me close a few things here. Too many things open. Cool. Close. Open. Close. This. Okay. Cool. I think you guys can still see this. Yeah. So, what the question asks Determine the maximum, minimum, and average pressure in the plate clutch with an axial force of 4 kilonewtons. The radius of the contact surface is 50 millimeters. The inside radius, sorry, and the outside radius is 100 millimeters. So again, what this is, it's just, you see, it's a very small demonstration. I'll start to sketch this for you. Oh man, is my tablet not on again? Let me just give me a moment. Let me just see. I can feel it's misbehaving. Yep, it's not linked. Aren't you linked? Just give me a moment. Yeah, it's not linked. Man, what's going on? What's going on? Okay, just give me a moment. Just give me this telephone. Okay, there we go. Looks like it's back. Where are you now? Okay. I can't see the cursor for some reason. There we go. Okay, cool. Everything's working. Happy. Okay. That's so cool. Can you guys see? Let me just like look small here. Cool. So across that friction surface, like I said, the pressure is not uniform in this case because we're dealing with uniform wear, right? And I should rather have it this way, where it decreases like that, rather. It's like a UVL of some sort. Cool. Very basic stuff here. Nothing crazy. Can you guys see my whiteboard? I'm just concerned. No, I didn't reload. Okay, I'm not exactly sure what's happening there. Okay, cool. That looks a bit better. Yeah. Nice. Okay, cool. So the form in question here, right? So if I can revert back to the slides, right? I want you to just be aware of the two formulas. So I'll write it here again. So for uniform, why is this happening? For uniform pressure, which obviously not, it's obviously not the one we're using now. And this isn't uniform way. I just want to get them down quickly. So these are formulas you have to know for them. Uniform pressure, it's going to be W. So essentially, they're all just let me write it here. W is, all of this is basically force equals stress times area. This is what they all are. For UP, it's going to be pressure multiplied by pi r big squared minus pi r squared small. So you'd find it there. Just get this right. R2 squared minus R1 squared. So this is obviously outside minus inside. This is for uniform pressure, right? For uniform wear, I should have rather written it like this. So uniform wear, your W now is the C 2 pi rather R2 minus R1. So I just want to just bring that to your attention of the difference between the two formulas. And like I mentioned to you right on top here, the general formula will be N, mu, W, and R. So depending on which theory you use, you have a different axial thrust formula and a different radius type formula. So I just want to make you aware of that. Okay. But in C here, C, which they call it the intensity of pressure, which is just essentially equals to P times R. And depending, and I'll obviously explain what all of this is now. So the C value doesn't typically change, but in this particular problem, yeah. So what we're doing now, so they want uniform wear. So this is the guy we're using, and I just want to close this here. Okay, I'm going to ignore that. So this is what we're using, and we are essentially looking at we find the values over here and the values over there, right? So first thing is first, they want the maximum, minimum, and the average pressure, right? So the maximum pressure, like I said, occurs from the inner radius. So this will be R1. Oh, no. That's R1, that's R2. Okay. So R1, small one, R2 is a bigger one. I think that's how they call it as well, I think. Or other way around. Let's call it other way around. So R2 is nomenclature here. R1 is the outside, and R2 is the inside. So like I said, this is not a typical problem, but just an idea of this using the C, this intensity of pressure kind of thing. So to find Pmax, so C equals Pmax times 0. What's my inside radius? My inside radius is 0.05, right? So what we're looking for is Pmax here. So what we're going to do, we're going to take this guy, the intensity of pressure as they call it, and substitute it in here. So our axial force is given, which is produced by our springs, that's 4 kilonewtons. C in this case is Pmax times 0.05, and that's going to be times 2 pi, and then it's basically the outside minus the inside. So obviously these values are different now, so it should be R1 minus R2. So 0.1 minus 0.05. So just have to change it up a bit now. Okay, cool. Can someone find me Pmax, please? We call it outside is R1 minus R2. Same thing. Yeah, we get that. It's outside minus inside. So what is my Pmax value? Are we all on the same page here? Are you guys following? Or you guys lost? Page 302. Mr. Jamili, what's my Pmax? Guys get Pmax? Yep, that's correct. And that'll be in Newton meter, or Newton per meter squared, or kPa. So here we have 254.65 kPa, basically. That's your highest pressure over there, right? That's what that means. R2s on the inside. So we know over here we experience a pressure of that much, not much, arguably, you know. So then we do exactly the same thing for the minimum size. So C equals P min and times R, but we know the minimum pressure will occur on the outside radius, and in this case the outside radius is at 0.1 over there. We do exactly the same thing, same axial force, P min times 0.1 times 2 pi 0.1 minus 0.05. Same thing. So what's my P min? What's the minimum pressure? This could also be expressed as that. Pressure equals force over area. Just by the way, if you are let's see, Paul. What is my P min? Get into uniform pressure and wear now. Don't worry. This is just a warm up. Zamunuba. What's that, P min? Guys, come on, man. Let's move. Yep. 127.32 kilopascals. Fantastic. There we go. 127. Nice, guys. 323. And what this essentially means is that on the far end, we get a pressure of 127.373. 373. 322 or whatever it is. Yeah. So that's just to demonstrate how the pressure is kind of changing on the friction surface, especially using the uniform theory. It's not uniform at all. And the last one, they want the average pressure, which you essentially just use a standard force over area. Now, that's not typical, but just to find, pressure, it's just if force equals force over area, and you just use basically the cross-sectional area of the contact surfaces. In this case, it's just going to be a 4 kilonewtons divided by pi r squared. It's just pi, outside minus inside. Not really important to me, but if you do find it, you're going to get around 170 kPa. So that's like the average pressure, arguably, like a line, we draw a line here or something across the two. What I do want to make you aware of, just using this formula, it's exclusively for uniform wear. Uniform pressure, the pressure is uniform, and you don't need to worry about this. However, when you're using uniform wear theory, you need to use your P max. Please don't make the mistake. I've seen students make that mistake. You have to use the maximum pressure at the uniform theory. We don't work on the minimum value. We work on that. I'm going to say that again. When you're using uniform wear theory, when you find a C value, and it's going to be for 2 marks typically, you have to find P max. The C, which is the intensity of pressure, it must be, you typically have to find C anyway. They'll give you P, then you have to times it by the radius, but you have to use this. Super, super, super important for uniform wear. Just making you aware. You don't use a minimum pressure. If you times by the wrong radius, you lose a lot of marks. So I'm saying it now again. Make sure for uniform wear, when you have to calculate C, which is the intensity of pressure, make sure you calculate using the minimum radius. Is it clear to everyone? Is everyone on the same page? Is it clear, students? Fantastic. Fantastic. Please. Now this is a more we're getting there. Okay. Let's make it more presentable. So this is now a good problem. Not a good problem. It's still easy. but it's going to demonstrate the theory for you. And I'd like you guys to work with this with me. And then obviously you can do one by yourself. I can obviously demonstrate it, and then you guys can, we can go for interval after this. Nice. Okay, I hope you guys see this. Lock it to see how it's, let me zoom in a little bit more for you guys. Yeah. So you might ask me, sir, do I have to know both theories? Yes, you do have to know both. Some questions may call for both, some questions may call for one. It's part of the game of learning where you have to identify, you know, and which formulas are appropriate for what particular application. Okay, right, so this is the question. A single plate clutch with both sides effective, obviously that means N equals 2 as an inner and outer diameters of a friction surface of 350 and 250, right? So they typically give it, you sometimes have to work the diameters, but then they give it now, respectively. The maximum intensity of pressure is not to be exceeded by 0.15. So that value is P, right? We still have to find C, which is the intensity of pressure. Well, we still have to find C rather. Just ignore my words, yeah. But it can't be more than 0.15. The coefficient of friction is 0.3, yes. Determine the power transmitted by the clutch at a speed of 2,400 for uniform wear and for uniform pressure. Right, and then determine the percentage reduction in the power between B and C. I think I asked this question in the final, if I remember correctly. Not something around this kind of way. Cool. So I hope that's clear to everyone. So we start with uniform wear, right? Okay, cool. Just get my thing. My white pen. Cool. So you'll be going uniform wear. Uniform wear. Now, again, my general formula, I always remember it's N times mu times W times R. And like I said, these two change, W and R, depending on which theory you're using. Okay, so for uniform wear, I'll start with the radius. R mean will be R1 plus R2 divided by 2. So straightforward kind of thing. You take the radiuses divided by 2. They're not too stringent on how they find the mean radius here. So in this case, you've got 35 and then 0.25. So it's 0.175 plus 0.125. Okay, divide that by 2. Let's just get that mean radius. I will be giving you the formulas. However, you need to make sure you know what to use for what. That's kind of stock standard here. 350. So I'll wait on you on my mean radius, and I'll do uniform pressure over here. Don't worry. Yeah, so you can have a look, so you can compare both. So can I get that value? Thank you. 0.15 meters, right? Make sure your value is always accompanied by a SI unit of utmost importance, right? So for your uniform wear, your actual thrust is 2 pi C or C2 pi whatever, R2 minus R1. In your textbook, yeah, it's there somewhere. Yeah, the equation is there for you. Okay, so like I said to you, we have to find C, and C is P times R, right? So this P value they give you there, I like to know which radius do I use to find my C value. Can someone get me C? Get me the answer. Just bring the question down for you again. Someone, can you please compute my actual thrust? I'll give you guys 2 minutes to quickly do that. Remember what I said in the previous thing. Yeah, the words are a bit weird here. You know, sometimes I get confused between the intensity of pressure. But anyway, that's P there. Pretty sure that's P. You can't use, yeah. But yeah, so C's unit is Pascal meter. Yeah. And the pressure itself is just Pascal. So that's the difference between the two. Okay, so let's get an actual thrust. Let's work this out. Let's see. What's very important is you have to use the right radius. Let's get the answer. What's that? 1/8. Yep, that's C's value. Definitely. Is it 18.75, right? Okay. Let's get an actual thrust. You guys can figure out how we got that. This will be Newton, sorry, kilopascal meter. Don't have to have a unit for C, just by the way. I don't really mind, I'm just writing it in. How did you guys get this? It's up to you. And now you can calculate your axial thrust. And that's it. Axial thrust is that force which holds the surfaces together. Right, I will bring it up again. So what's that axial thrust? Is everyone on the same page? Mr. Gumede, Tsepo, Mr. Asa, are you following? Mr. Jamini. What's my axial thrust? Are you guys keeping up? So in this case, this will be 2 pi times 18.75 times 10 to the power 3. 0.175 minus 0.125. And you should get an answer of, let's see there. Do I agree with the answer? Yeah, fantastic. 5890.48. Amazing. 5890.48 newtons. Cool. And once you've done that, as you can see in that formula over there, we've got W and we've got R now for a uniform wear. Now we can compute the torque. So it's two surfaces, single plate clutch. Again, what is N? N is the number of contact surfaces, flywheel, and the clutch plate on the, arguably on the left-hand side. If you can see it, and on the right-hand side is the pressure plate and the clutch plate. Our friction over there is given as 0.3, right? Now we can times by W, 0.48, and obviously we can times by our radius, and that's going to be 0.15. Sweet. And we can get our torque. And what is my torque value? Yep, 530.14. You guys will get that? $530.14 Newton meter. Super important. And to get our power, it's simple, 2 pi and T over 60. 2 marks for this. Just as an illustration, you guys can figure out that. Let me just show you how your marks look like. You get 2 marks, obviously, was using the right formula there. You get another 2 marks, right formula, another 2 marks, and you probably get 1 mark here. Oh, and you get a mark for this. That's 1, 2, 3, 4, 5, 6, 7, 8. Might even get 10 marks for a question like this. This is the first half of it anyway. So your power will be, excuse me, two pi. They've given us a rotational speed of 2,400 times 530.14 divided by 60. Nice. 133.24. I'm not going to just call it that. Yeah, 133.24 kilowatts. You probably get 2 marks here actually. I know myself. Okay, so that's roughly how something like that will look. Sometimes you have to use uniform wear and uniform pressure. Guys, are there any questions with this particular thing? Any questions at all? Or is anything confusing you? Do you understand what I did here? This is what I'm doing. The two main theories you basically can apply all over. All what's going to happen is they're going to change, ask you for radiuses, ask you for that. Any questions, my students? I'll give you 2 minutes for questions and we'll do the uniform pressure theory. Where do you get the formulas? Blah, blah, blah. Anything at all. You're free to engage. Why did we use n equals 2? Like I said to you, Mr. Swanepoel, it's about the surfaces. So let me get that back for you again. For a single type clutch, n is always equal to 2, and I'll paste that note here so you can see. So as you read here, it says consider a single plate clutch. It consists of 3 plates: the flywheel, the friction plate or clutch plate, and the pressure plate. And there are two pairs of surfaces in contact: the flywheel on the one side of the clutch, and the other side is the clutch plate and the pressure plate. So to find the number of contact surfaces, essentially is the number of plates minus 1. So remember, there's 2 sides when you're transmitting the torque, basically, if you think about it, not just the one. That's why we use two frictional surfaces. You got it? Write down this formula for yourself. Oh, using the wrong. Torque equals force times radius. Well, in this case, we're dealing with a frictional force, right? So with a frictional force, we go mu n or mu f. It's a force, right? That's that. You've got a radius, but now because of the 2 sides, you've got that. So this is in essence n, but obviously this remains n. You know what I mean? That's the idea. It's still force times radius. Any other questions, guys? Any questions before we move on? No other questions? Guys, are you sure there's no questions? Mr. Wheeling, do you have something to say? All right. Nope, nothing perfect. Okay, fantastic. So now we look at our new theory, the next theory rather, which is the uniform pressure. So again, uniform wear, like I said to you, is for when the clutch is old. So when you're buying a new clutch and installing a new clutch, let's see how much torque will be transmitted. Not sure why is my thing doing this. Okay. So like I said, it's the same formula. However, we have to now, our W and R essentially changes, right? So our effective mean radius now is 2/3. And if you're curious on how they got the formula, there is a whole page explaining this, but it's essentially to do with integration, where they integrate the area. And lucky for you, you're not required to integrate any fancy areas, just apply the formulas. So it's quite easy to remember. That's the outside radius. What do we call the outside? R1 cubed minus R2 cubed. And then again, R1 squared minus R2 squared. So it's basically outside minus inside times 2 over 3. So can we get that mean radius? So just remember for uniform wear, different type, very basic. For uniform pressure, the effective mean radius is a bit more complicated. So let's get that uniform. Is everyone happy with that? 0.15154. Mr. Nima, you got it? 0.1514 meters. I think that's correct. I think it is, yep. And then once that is done, we have to find our axial force, right? Again, produced by the springs, or basically or rather, you could call it the force, which keeps the surfaces in contact, rather, also call it that. And in this case, it's just P times pi R2 squared or R1 squared, whatever you want to call it. Why do we call it R1 squared rather? Minus R2 squared. Right, again, guys, this is force equals pressure times area. That's all that is. Nothing fancy. Nothing fancy at all. Just close all these things here. It's bothering me. Cool. So the pressure was given to us. So with the uniform pressure, we don't have to find that C value because the pressure is uniform. We just use the 0.15 times 10 to the power 6. That's all we have to do. And that's given over there. Times it by pi, and which will be 0.175 squared minus 0.125 squared. That's all. Let's get the actual thrust. Let's see how much force is given here to maintain contact between the frictional surfaces. Let's see. Yep, 706.58. Fantastic. To see Madrigetas. Mr. Swanepoel, are you following? Mr. Siningrum, you've been quiet. Prof. So obviously we see a bit more force. Fantastic. A bit of more force. And all we have to do now is apply the same formulas, 2 times 0.3, and obviously with our new values here, so 7068.58 times 0.151 4. Just get this right here. And that equals to, what is my torque value? That's Newton meter. And we're expecting a higher torque, like I said, obviously, because the clutch is still fresh. Hasn't had a lot of experience yet. And we should get 642, is that correct? Yes, 642.1. Looks legit to me. 642.1 Newton meter. And just compute our power. What do we get there? Let's see, 161.38. You guys get this? Any questions up until now? Is the concepts being articulated clearly? Are you guys following? Guys, any questions? Don't be shy. Mr. Silver, Mr. Gumede, Mr. Tito, Mr. Smulders, you've been quiet. It's 161377. Sweet. Yeah. So that's what's important to note the different theories and the different formulas used. And the last question I asked, which is like a bonus type question, determine the percentage reduction in between power B and C. So assuming you didn't let's see the importance of maintenance here, and why you have to replace your clutch. To find the percentage difference, really, you just have to take the 161.38 minus the 133.24 and divide that by 133.24. And if you do that, I should have probably said in percentage, but anyway, 133.24. You get a 21.18% difference. So that's what happens if you don't change your clutch, right? You lose around 20% of the power which you're supposed to initially transmit. So that's part C if you are interested. So guys, that's why maintenance is important. Change those clutches. Otherwise, things won't operate as they're required to. And I mean, 20% here also talks to a 20% increase in fuel, possibly. Or because I mean, let's say, for instance, you're transmitting the less amount of power now. Instead of 161, you're only transmitting 133, sorry. So any questions thus far? Before we proceed to our interval, just to get the blood flowing again. Any questions, students? How are you finding the sections thus far? Easy? Are you enjoying it? Great. Fantastic, fantastic, fantastic. Okay, any other questions? Coffee time, sir, please. Definitely. Just wait for 2 or 3 students to say anything and then we can. Okay, guys, I'll just wait a minute. Why would it be that? What it's possible, we can call it that, but the idea of why I chose that, if you take 113.24 times 1.218, you'll get the 161. I initially did that yesterday and I was thinking about that so we do this and then we divide this. Maybe I should word the question clearly. Yeah, we get a different percentage thing. 161.38 minus 133.24. Yeah, you get 17%. So what this means is a 17% drop in power. Yeah, maybe you're right. Yeah, using this as the reference, so you could say, yeah, it's a 17% drop in power. I was looking at this here. Now we lost 17%. Ignore my 21%. Okay, cool. Any other questions? I just kind of threw the question in there. Actually, it wasn't actually there. Okay. I'll just get back to the slides quickly. And what I'll leave you with, just as, and obviously guys, whatever I have is practice on the slides, make sure you do it. All these notes are available for you. Maybe what you can do just as to test yourself while we have our interval, go over these practice slides, and I think the slides are on Blackboard anyway. Everything's on Blackboard. Try and do number one. If you guys find any problems, I can obviously do it, but it's a straightforward thing as well. Just giving you an idea of how to do it. And there's also a nice one here, the 1.4. You have all the solutions there already. Yeah, and after this, we go into the other half of the section, which will be, because it's the interval section, so you guys can, this is all practice problems essentially for you. I just put them here in your face so you can obviously see what's important to practice in your textbook. We're going to go into the springs. When the springs wear out, I'll do one or two problems, and then you guys can go practice. And I think from next week we'll start on multiple plates, clutches. Yeah, we'll figure that out. Cool. Anyway, so I recommend now during the break, your interval, make sure you try to do practice one, and yeah, just at least start to get these values. Oh yes, and then nevertheless, just to show you that you're correct, I've posted the solution easier for the slide for that particular problem. Super important. Friction is typically very easy marks to actually get. Obviously, these are the easier type problems. Other ones you have to kind of work backwards, things like that. But it's nothing too much for you to handle, honestly. But what's key is what's important. Know the importance between uniform wear, uniform pressure, and know what things to use. Like 1.4 can be a bit of a tricky one because there's a lot of messy math you have to work through there. But I can always do that again. That's not really important. Also 10.24, we have to find the radiuses. That can be a bit of a mess. Not a mess, it's just a mathematical thing. Anyway, let's have an interval, guys. Let's come back at 10:45. 15-minute break. I do recommend you practice this problem now. It should take you 5-10 minutes. And again, don't ask me, sir, is it uniform wear or uniform pressure? Read the question. If the clutch is new, uniform pressure. If it's worn, uniform wear. You should know that. Don't ask me in the test. I don't even want to have a conversation, and you should know which formulas to use. All right. See you at 11:15. I think I need another cup as well.